and welcome back to Algebra 1. Our goal for today is to continue working with our solving when we have equations and inequalities. And for today, we're going to start to look at what are called proportional equations and inequalities. So we're going to start with our proportional equations. Something you need to understand about proportions and how they're set up is they are made from what are called ratios, or numbers that can be written as a comparison of two values. Now, we technically have three ways we could write a ratio. The word 2 in between our numbers, right? We have 2, 3, as a fraction, or with our colon. Our proportions use this fraction version of our ratios, where we have some amount of something being compared to some amount of something else. All right, so a proportion takes two of those ratios and sets them either equal to each other, or maybe greater than, less than, greater than or equal to, or less than or equal to if we have a proportional inequality. But for today, we're going to look at when we have proportions that have equal signs, called proportional equations. So if I have a fraction on one side, an equal sign in the middle, and a second fraction or a ratio on the other side, I have what's called a proportion. And so our goal for today is, if I'm given that setup, fraction, equal sign, fraction, and one of the four values in that proportion has an unknown or a variable, something that looks like this, where there's an x, or maybe a 5x, or an x plus 2, or something like that. In one of the four locations, can I use a method called cross products to help me solve for that variable or that unknown? Now, cross products is not our only method for solving proportional equations, but is the method that we are focusing on right now. So I would like your steps to support this particular method for right now, called cross products. So the way that cross products works is, if I use those words to sort of help me, it helps me get organized to set up my first step, which is cross in this case just means things that are diagonal, and product means multiply. So I'm going to take things that are diagonal and multiply them. Once I've done that, I've taken things that are diagonal and multiply, I'll be back to an equation that I know how to solve. Maybe a one-step, maybe a two-step, maybe a multi-step, maybe a variables on both sides, but it'll get me back to a problem I should know how to use inverse operations to help me solve. So my suggestion to help you with that cross product part that gets you started for these proportional equations is start in your denominators and think up and diagonal, right? So I'm starting with my 12, up and diagonal around. I start with my 8, up and diagonal around, and I bring down my equal sign. That's going to help to make sure you end up with the correct products on each side of your equal sign. So this arrow that says work over here in front of your equal sign connects the 8 and the x. We need to find their product. The other thing that's going to help you is, when you go to do your multiplication for these problems, use parentheses to show your multiplication, not a dot or an x or some other form or method of multiplication. It's going to help you from making little mistakes along the way. And inside of your parentheses, always put the letter that's also going to help you. So if I have 8 and x I need to multiply here, my suggestion would be 8 parentheses x in that order. Now, I could put the x in the front and the 8 in the back. It's just this version where I put the 8, then the parentheses and the x is going to help me the most as we go through more complex problems. Now, on this side, I have a 12 times 2. Again, I would use parentheses. I can have the 2 out front and the 12 on the inside. That wouldn't change anything. All right, from here, I would have an 8 times x, right? 8 times x would just give us 8x. A 12 times 2 would give us a 24. And I would hope from there we understand that this is a one-step equation where all we would have to do is divide both sides by 8, and we would end up with our value of x, which in this case would be a 3. So that's our goal for today. Can I use cross products method to help me solve proportional equations? So go ahead and fill in your steps. Hit pause here on the video. Fill in your steps on how we go about using cross products to help us solve proportional equations. All right, we're going to connect our diagonals, find the products, and we'll be back to a one-step, two-step, multi-step, or variable on both side equation. Please remember, when we have variables on both sides of our equal sign, we might end up with one of those special cases where we either have a true or false statement. We're not done until we identify if it's true, we have all real numbers could be solutions, and if it were false, there's two things I need to do: slash my equal sign and state that there would be no real solutions in that particular case. Our inverse operations will remain the same once we get back to what our problem looks like with a one-step, two-step, multi-step, or variable on both sides problem. So let's look at some examples. Start kind of simple and build from there. All right, we want to solve for the variable z when we're told that the ratio of 3/7 equals the ratio z over 63, right? Or we have fraction, equal sign fraction, which indicates to us we can use cross products to solve. Now, I'm going to start my denominator. 63 times 3 should end up in front of our equal sign. I'm going to use those parentheses to help me as the problems get a little bit more complex. And then behind our equal sign should be a 7. And I'm going to use parentheses and always put my variable on the inside. It's going to, again, help me as the problems get more complex. All right, do your multiplies. 63 times 3 on the one side, 7 times z on the other side. We'll have a 189 equals 7z. All right, once we get here, we've connected our diagonals and we found our products. We'll either have a one-step, two-step, multi-step, or variable on both sides equations. In this case, we have a one-step where all we have to do is eliminate a times by 7 by dividing both sides by 7. Cancel on the one side, bring down our variable z, which was our goal, get our variable by itself, do our divide on the other side, and we'll end up with a 27 equals z. Good final. Number 2. I want to solve here for our variable w when we're told that the fraction or ratio 1726 equals w over 52. Since we're in the format of fraction, equal sign, fraction, we can use cross products method to help us solve. Again, bring your equal sign straight down, connect your diagonals, and find their products. So 52 times 17 would be in front of our equal sign, and 26 times w, and I'm going to put parentheses with w inside it, that's going to help us the problems get more complex, has to be behind our equal sign. Make sure you follow those arrows correctly. All right, from here, find their products to simplify. So 52 times 17 would give us an 884. And 26 times w would just give us a 26w. All right, once we get here, we'll have a one-step, two-step, multi-step, or variable on both sides problem to solve. In this case, a one-step, where all we have to do is get rid of our times 26 by dividing both sides by 26. All right, cancel on the one side, bring down our w. And 884 divided by 26 on the other side would give us a 34 equals w. All right, so if we were to think about that original problem, the fraction 1726 is equivalent in value to the fraction 34/52. All right, number 3, we want to solve here for the variable k. Since we're in the format of fraction, equal sign, fraction, cross products can help us solve. Bring that equal sign straight down, connect your diagonals, and find their products to get started. In front of our equal sign, we needed 3 times 18 in any order, but I would use parentheses there to show that multiplication. It's going to help as the problems get more complex. Behind our equal sign, a 45. I'm going to use parentheses with my variable inside the parentheses. Again, that's going to help me as it gets more complex. All right, we've done our cross part. Let's find our product. So 3 times 18 would give us a 54. And 45 times k would just give us a 45k. All right, we have a one step from here. We need to get rid of a times by 45 by dividing both sides by 45. All right, cancel the one side, bring down our equals k. On the other side, 54 divided by 45 is going to give us a decimal amount, so we have 2 ways to express our answer here. It's a decimal that terminates, so we can write it as 1.2, Or we could think I could simplify and end up here with a 1 and 1/5. Both perfectly fine, acceptable ways, since they both represent the exact answer to what k is. If this didn't terminate perfectly, we would have to get the exact fraction. So just be careful. Unless I'm told I'm allowed to round, I have to get the exact final answers. All right, number 4, we want to solve here for the variable x. Now, this problem looks a little bit different from the others that we've done so far because x isn't by itself in its location in its ratio or fraction, but our cross products method still works because we're in that format of we have a fraction, equal sign, fraction. So we want to start by connecting our diagonals and finding their products. That will always get us back to a problem we know how to solve of a 1-step, 2-step, multi-step, or a variable on both sides. So let's get started. Bring down our equal sign. In front of our equal sign, we should have a 3 times 6x. Again, use parentheses and put that variable inside. It's going to help you as the problems get more complex. All right, behind our equal sign, a 12 times 9 in any order. Right, our side with just 2 numbers, we can multiply, or we can put 9 times 12, it would be the same. All right, that's our cross part. Now let's do our products. Over here, this is a 3 times 6x, right? It's one big multiply still. So 3 times 6 gives us 18 times x. So 18x equals, and then over here, our 12 times 9 would just give us a 108. And now, even though it looked a little bit more complex in the original problem, so once we get here, we still just have a 1-step equation where all we have to do is divide both sides by 18. All right, cancel on the one side, bring down our x equals. On the other side, our 108 divided by 18 will give us an x value of 6. Good final, box it on in. All right, number 5, similar to number 4, where we have something a little bit more bigger, a little bit more complex in our denominator of our first fraction or ratio. But as long as we have that format of fraction, equal sign, fraction, then we can use cross products to help solve for our variable m. So let's get organized here. Bring our equal sign straight down. Connect your diagonals. That's your cross product, cross product. So 10 and 18 have to go in front of our equal sign and be multiplied. And 9m and 5 will end up behind our equal sign. I would always suggest use parentheses and put your variable inside. It's going to help as problems get more complex. All right, that's your cross part of cross products. Now do your multiply. 10 times 18 would just give us a value here of 180. And 5 times 9m would just give us a 45m. And what looked more complex to begin with still gets us back to a 1-step equation where all we have to do is divide both sides by 45 to solve for the variable m. All right, cancel on the one side, bring our variable m down. 180 divided by 45 then would just give us a value of 4 equals m. All right, number 6, a little bit bigger, a little bit more complex than any that we've looked at so far. But again, it's in that basic format of a fraction on one side, an equal sign, and a fraction on the other, which indicates to us I can use cross products to help me solve. So equal sign straight down. And now you're going to start to see why I think it's super important to use parentheses and putting your variable inside those parentheses when you show your multiplication. Because in front of our equal sign, we should be multiplying a 9 times the entire thing, x plus 1. So we have a 9 times the entire math problem, x plus 1. And now instead of just a multiply over there, we have a multiply that's going to result in having to use the distributive property. So be careful. All right, behind our equal sign, we should have a 2 times 5. All right, that's our cross product, part of our cross products. Now do your multiplies to get the products. Over here, we have 9 times x plus 1. So 9 times x and a 9 times a 1. I have to expand using the distributive property over there to get a 9x plus 9. And then over here, 2 times just one thing inside of here, a 5 would give us a 10. And now instead of getting back to a 1-step equation, we have a 2-step. So it might be helpful here to put your box, cover up your x term. we need to eliminate the plus 9 first by doing the inverse operation of subtracting 9 from both sides. Cancel on the one side. 9 minus 9 would eliminate, leaving us with 9x. And 10 minus 9 would just give us a value of 1. And now we have a one-step equation from there where we need to divide both sides by 9. So 9x is going to get divided by 9, and our 1 is going to get divided by 9. So x in this case would be 1/9. That's the fraction version in its simplest format. All right, number 7. All right, again, a little bit bigger, a little bit more complex here. We have a fraction of 3/10 equals b plus 7 over 20. Since we're in that format of fraction equal sign fraction, then we can use cross products to help us solve for our variable b. Your equal sign down. In front of your equal sign, a 3 times 20. Behind our equal sign, a 10 times b plus 7. All right, that's the cross product of your cross product. So now multiply to get your product part. 3 times 20 gives us a 60. Over here, we have 2 terms inside of our parentheses, so we have to expand using our distributive property when we multiply. So 10 times b would give us a 10b, and 10 times 7 would give us a plus 70. And once we get here, we'll see that we now have a 2-step equation we have to solve. So box, cover up our 10b term, and what we still see, a plus 70 is what we'd have to eliminate first. So we're going to start by subtracting, and the amount would be a 70 from both sides. All right, eliminate on the one side, bring down our 10b. On the other side, 60 minus 70 would just give us a negative 10. All right, from here, one-stepper where we had to eliminate 8 times by 10 by dividing both sides by 10. Cancel on the one side, do our math on the other. So negative 10 divided by 10 will give us a negative 1 equals b. Good final, box it on in. All right, number 8 is a little bit different than anything we've looked at so far. It says 14 equals 6 plus z over negative 2. And right now you're probably saying that's not a proportion. We don't have our format of fraction, equal sign, fraction. And so the way that this is written, we wouldn't be able to do cross products. However, when we have a whole number like 14, we can write it as a fraction because it's technically a 14 on top and a 1 in the denominator. And if I add the denominator of 1 over here that's technically there, now we have a fraction, an equal sign, a fraction, and we can use our cross products method to help us solve for our variable z. So bring down my equal sign, connect our diagonals. So 14 times negative 2 would have to go in front of our equal sign, and our 1 times the entire thing, 6 plus z, would go behind our equal sign, and now we can go back to our multiply. 14 times negative 2 get negative 28. 1 times 6 is still just a 6, and a 1 times z is still just a z. Now I can put 1 z there instead of just z, and that would create a 2-step problem, or I could write it like this with just a z there, which would create a 1-step problem. Both are perfectly fine. Both will get you to the same exact final result. So I'm going to leave it like this in its more basic, simplified version, which will result in just needing a 1 inverse operation to help us solve of subtracting a 6 from both sides. And in this case, we end up with a negative 28 minus 6, which would give us a negative 34 for our value of z. If I still had 1 z left over here behind our equal sign, then a second inverse operation of dividing both sides by 1 would get us to the same result of negative 34 equals z. All right, number 9, same idea here. We have a whole number, or in this case, integer number, then it equals a fraction. So right now, it's not a proportion. We do not have that format of fraction, equal sign, fraction. So we want to get it back to that format of fraction, equal sign, fraction. And the way to do that is to take this integer number and put that, it technically has a denominator, and that denominator is always a value of 1. And now we have the format of fraction, equal sign, fraction. We can use our cross products to help us solve. So we end up over here, negative 11 times 6, and a 1 times a minus 5. Do your multiply to get negative 66. 1 times a is still just an a, and 1 times negative 5 is still a minus 5. Now again, I could have 1a minus 5, which would result in a 2-step problem, or I could leave it like this as just a minus 5, which would result in a 1-step problem. So again, I'm going to keep it as simple as and basic as possible here, and just use it as a minus 5, which would require an add 5 to both sides. If you have a 1 as a coefficient in front of your a, then I'll take a second inverse operation of dividing both sides by 1. Either way, both will give you to the final result of negative 61 equals a. All right, last couple are a little bit different. We'll call this your number 10. Because they will result in variables on both side equations. Now remember, when we get variables on both sides, we can have those special cases, so be very careful. To start, we have fraction equals fraction, so cross products will help us solve. 3 times our entire thing, 9b minus 3, and a 9 times 5b plus 5. All right, we're going to have to, when we multiply here, we're going to have to distribute on both sides of our equal sign. So 3 times 9b, which would give us a 27b, and 3 times negative 3, which would give us a minus 9. Over here, a 9 times 5b, which would give us a 45b, and then 9 times positive 5, which would give us a 45. And now I would say, all right, there's nothing left to simplify on both sides, so I want to try to get my b variable all in one location. Most of us have been taking this back letter variable term and moving it to the front, so I'll continue to do that by subtracting a 45b from both sides. I'm going to get all my letters in one location before I worry about any other inverse operations. We have 27b. We're going to subtract our 45b from it. We have our subtract 9. And then over here we have our 45b. Again, we'll subtract 45b from it. And we have our plus 45. All right, these are opposites. These ones are going to cancel, leaving us with 45. Over on the other side, 27b minus 45b would just give us a negative 18b minus 9. And then once we get here, since b did not disappear, it's not a special case, we have to keep solving until we get what b equals, and it's a 2-step problem. So we're going to add 9. Both sides get started with our inverse operations. And then we'll have to deal with the fact that we have a times and negative 18 on our side still with b. All right, 45 plus 9 more would give us a new total of 54, my bad. All right, from here, one stepper, take your negative 18b and divide by negative 18. 54 divided by negative 18. And we'll end up here with a negative 3. Good final value for b. All right, last one, and it's going to result into a variables on both sides. So remember, our special cases could happen here. All right, bring our equal sign down. Cross products, 5 times 3n plus 3 in front of our equal sign, and a 10 times 2n minus 4 behind our equal sign. It's going to take a distribute on both sides to do our multiply. So 5 times 3n would give us a 15n. 5 times 3 would give us a 15. And 10 times 2n would give us a 20n. And a 10 times negative 4 would give us a minus 40. All right, from here, we want to get all of our n terms in the same location. So let's take this 20 and bring it to the front by subtracting a 20n from both sides. 15n minus 20n plus 15 equals our 20n minus 20n minus 40. All right, cancel on the one side. End up with a negative 40. Over here, these are not opposites, so if we don't have a special case, we're going to have to keep solving. We'll end up with negative 5n plus 15 equals 40. All right, two-stepping from there, we need to subtract, and the amount is a 15 from both sides. And we end up with negative 5n equals, and then our negative 40 minus 15 will give us a negative 55. One stepper from there, we're going to divide both sides by negative 5. And we end up with a n value of 11. All right, I hope that helps you guys attack your work for today. See you guys later.